Hello, good morning, everyone. Can you hear me clearly?
Yes.
Yes, I can hear you. But please let us put your screen in.
That's what I want to do.
Okay.
So good morning. Today I will be talking to us about algorithms and data structures in programming. So let's get right into it. So an overview of an algorithm. So an algorithm, the word algorithm means a process or a set of rules to be followed in calculations or other problem-solving operations. Therefore, algorithm refers to a set of rules, instruction that step by step define how a work to be executed in order to get the expected result. So an algorithm basically is a particular process, a step-by-step process in executing a particular task, so you get an expected output. So this is just a block diagram of how an algorithm works. So it takes in input, then this set of rules or instructions are applied to that input and process, and then you get a particular output you are supposed to get. Moving on. So it can be understood by taking an example of cooking a new recipe. To cook a new recipe, one reads the instructions and steps and execute them one by one. In a given sequence, the result thus obtained is a new dish cooked perfectly. Similarly, algorithms help to do a task in programming to get the expected output. The algorithm design are language independent, that is, they are just plain instructions that can be implemented. So basically what this part is saying is, if you take it that you have a particular type of jollof rice you want to prepare, right? So there are particular ingredients you use in preparing this jollof rice, and there are particular processes specific to this jollof rice. Now, these steps are written, let's say if they are written in a recipe book. Now, no matter the language, right, would be it Yoruba, Chinese, Igbo, Hausa, Japanese, or whatever language this recipe is written in, or this set of instruction is written in, you know that once you follow these instructions and use this particular recipe, you must arrive at this particular type of jollof rice. That is what it means by being language independent. No matter the language your algorithm is written in, you have to get, if you like, you have to get a particular, the same output. That is what this thing is saying, and that's what it meant by being algorithm has to be language independent. So these are just characteristics of algorithms. So they have to have a well-defined inputs, clear and unambiguous, language independent. It has to be feasible, finiteness, and well-defined output. So when we say clear and unambiguous, the algorithm should be clear and unambiguous. Each of its steps should be clear in all aspects and must lead to only one meaning. That is, each step you implement in your algorithm has to be well-defined and has to be has to lead to the next step. You can't just jump pack rubbish and say and call it your algorithm. It has to be clear and defined, and then well-defined input and well-defined output. That is, your input and output have to be well-defined. So you can't just if the instruction for the algorithm says the input has to be, let me say, it has to be a float, you can't just put in an integer. It has to be a float. If it says the output has to be an integer, it has to be an integer. You can't just get a float and then walk away. It won't work like that. And then finiteness, the algorithm must be finite. That is, it should not be running in an endless infinite loop. It has to stop at your output. Where you get your output, the algorithm has to be terminated. And then feasible, the algorithm must be simple and generic, so it should be able to run on different computers or different machines. And then language independent, which we've talked about. Whether you are using JavaScript, PHP, Solidity, Python, or Golang, or whatever programming language you are using, you have to, the algorithm has to give the same output. Taking the same input, it has to give the same output across these different languages. So how to design an algorithm? And in order to write an algorithm, the following things are needed as prerequisites. The problem that is to be solved by this algorithm, the constraints of the problem that must be considered while solving the problem. So during for those of us in the tech team, during the weekly drills, the hacker rank questions we are usually given to go and work on, you discover that they are usually constraints. You discover maybe they'll say the output should be, Some people might say the input should probably have a particular constraint. It should be between the output and 40, something like that. So there's usually a constraint for these programs, right? So the algorithm doesn't have to pass this constraint. It has to be within this constraint. So the input to be taken to solve the problem, there has to be an input and there has to be an output also. And then the solution of this problem is the given constraint. So the solution to this algorithm is usually within the constraint. You just need to know how to look for it. Moving on. So evaluating algorithms, right? So in things like competitive programming or during job interviews, you getting your output is not just okay, right? If they say if your output is supposed to be 5, maybe you are taking in let's say the algorithm says print out sum of 2 numbers that has to be 5, and you do 2 and 3. Now, you using 2 and 3 gives you 5. Now, even though you get 5 and use 2 and 3, even though you get 5, during evaluating of this algorithm, you might fail it because of what we call space complexity. Now, you need to write your code in such a way that it takes the smallest possible memory on your computer to run, right? If someone else writes the code and it takes very little memory to run on your computer, and then that person beats you, even though you get your specific the required result, it needs to take the smallest memory possible to run. Now, there are 2 variables used to evaluate space complexity. They are the fixed part and then the variable part. Now, if you notice, if you go to places like HackerRank and LeetCode also, you'll see before you submit your code, it's a place where I think you run your code, and then there are particular tests which run on the code, and then those tests, you see that they begin to tick some parts which your algorithm pass. So if your algorithm doesn't pass those every of those tests, the space test and the time test, and then even though you get your required outputs, you didn't pass. So it needs to take a particular, like, the smallest possible space in our local machine to run. Also, time complexity, it needs to take the smallest time to run. Even though our computers are usually fast, it might take like maybe less than a second to run. Someone else's algorithm might take 0.5 of a second to run. So it just depends. You need to write your algorithm in such a way that takes the smallest space possible to run on memory and the smallest time possible to run. And then also time complexity also takes 2 variable. That's to calculate time complexity, which is the constant time part, and then the variable time parts. All right. So we are moving on to data structures. So data structures is a particular way of organizing data in a computer so that it can be used effectively. So in computer science, or in computers generally, when you assign a variable, when you assign a value to a variable, right? This variable has a location in memory, right? They have different locations in memory, and then these memories also have addresses. Now, when you want to use this variable, now that is when the computer goes to that particular address where it is in memory and fetches that variable, right? And fetches that variable for you to use. So there are different type of data structures. So I just picked a few actually. There are so many. There are arrays, linked lists, stack queues, binary trees, and then binary search tree and strings. So let's look at arrays. So an array is a collection of items stored at contiguous memory locations. The idea is to store multiple items of the same type together. This makes it easier to calculate the position of each element by simply adding an offset to a base value. So an array is basically a collection of different how I call it, different variables, right? So in Python, an array is what we call a list. I don't know, in other languages it might be an array also. So basically it's a collection of different variables inside. Let me say a container, your square bracket. Let me just use the word container. So an array can be unsorted, an array with types of arrays. We can have sorted array or unsorted arrays. And then some of the common operations that can be done on this array that you encounter are just basic operations that you can encounter in, I'm not sure you encounter this type of operations in job interviews or hacker rank or your hacker rank and lead code competitions. These are basic operations. So you can perform search, insert, and delete operations on sorted and sorted arrays. So sorted arrays are basically arrays that are arranged, let's say arrays of numbers that are arranged alphabetically, like sorry, what's the word again? In increasing or decreasing order, but in their respective positions, like 1, 2, 3, 4, 5. And when you have, instead of 0 points, not instead of scattered, having it scattered. Now, so in search operations, in an unsorted array, you have the numbers arranged in no particular order, right? It just arranges them. So when you're trying to perform search array, you have a particular index, right? So you are asked to get the value of that index. So in this case, let's say, and you know, in programming, we start counting from 0. So 0, 1, 2. So 3 now, 3 has the index of 2. And then, so if you want to perform search operations in Python, I think this will be, let's say the name of the array is ARR, let's say R, so it will be R dot, and then square bracket search, then the index, which is 2, and then it will print out 3 for you. So then, okay, search operations, and then insert operations, basically. So you have to insert, this is inserting a value into the array, a new value that wasn't initially in the array, then it's inserting it. But in inserted arrays, this you have to put in this value where it's supposed to be. Let's say, like in this case, you have 1, 2, 4, 5, 6. Now, if it was an unsorted array, you have 1, 2, 4, 5, 6. Now you need to put in 3 in between 4 and 2. You can't just put in 3 at the end of the array. That would be wrong. So, but in an unsorted array, you can just put it behind and you are good to go. So I think the way to do this is, I'm using Python as a use case. I don't know how you do it in other languages, but in Python is array dot insert, and then the index of where you want to put it, and then you print it again. You get your required output. Delete operation basically is popping out, is removing the array, removing a value from the array or the list, and then notice that the array will readjust, right? After removing the particular value, it will readjust and give you the new value of the array. So you can use the index of the array to remove a particular array, or you can just pop out one array depending on the question or the type of task you are performing. Pop out an array. Sorry, pop out a value from the behind, like the last value of the array. Now, also strings can be considered like as a special type of array. So a string is basically a collection of characters. Now, which makes sense actually because they are a collection of English alphabet, so they actually make sense. But they can be seen as an array. So remember, so when I talked about address, this. If you look below this table, these are like the address and examples of an address in your computer memory. So each of these are assigned a location in memory. So these are the individual addresses. This is how an address looks like. So when you want to use the particular variable, the address bus goes to this particular address and fetches this variable for you to use. Now, some common type of operations which you might encounter in programming interviews, or depending on whatever you are doing, be it competitive programming or just for fun. Some of this, the common thing is pangram. So a pangram basically is checking if a sentence contains all the letters of the alphabet. So an example of this is the quick brown fox jumps over the lazy dog. This contains all the 26 letters of the alphabet. So they might ask you to check if a particular sentence is a pangram. right? And then square word also is a common. This one is not that common naturally, but okay, this this particular question was given to my friend for a particular interview. If you know Turing.com, where like once you pass their interview process, you are paired to Silicon Valley companies to work in. So they gave him particular task and he couldn't even do it, and he just left the interview midway. So a square word is basically a word. Let me just show you a square. Now this is a square word. Now they ask you to check if this particular group of words are square word. Now a square word is if it spells a particular word horizontally, that's in the first row, it has to spell the same word in the first column. If it spells this a particular word in the second row, it has to spell the same word in the second column. So they give you a group of words, and if you see this example, heart is the first row and heart is the first column, ember is the second row, and ember is in the second column, and so on and so forth. So you ask you to check if a particular group of words are square words. The truth is, this is actually a very difficult thing to do, but you need to, once you are into algorithms and data structures and you've dedicated your time and effort into it, I'm very sure you'll be able to pass this in no time. And that was a 30 minutes, a 30 minutes question. So where can you learn algorithms and data structures? You can go to HackerRank, which we are usually giving questions from HackerRank every Wednesday on our weekly drills, and go to Lead Code. Go to Algo Expert. I'm very sure if you're a developer, if you have been to YouTube, you must have seen Algo Expert ads all over YouTube. So I think Algo Expert is paid, but it's owned by an ex-Google engineer. So he uses Google standard questions in this, and you can also check his YouTube channel also. So he does mock interviews, like mock Google interviews. I think his name is Timothy also. So he does mock Google interviews on his YouTube channel also. So you can see how those type of questions are. Also, you can check out, you can buy courses on Udemy, Udacity, or Coursera, or on YouTube. So you can just check out which of your favorite place to buy courses. You can just check it there. And you can also, I think Udacity has a free course on algorithms and data structures. You can also check YouTube. I think Free Code can also have a course on algorithms and data structures. There are so many places you can get. You can go to Geeks for Geeks. You can go to what's it called? W3 schools. There are so many places online where you can learn this for free. Also, why you should learn algorithms and data structures. So it enhances our ability to solve problems more efficiently, and so basically, if you're into algorithms and data structures, and once you've worked on it very well, you discover that programming becomes easier to you generally. And actually, you need serious time and dedication to become really good in algorithms. You can't learn it in 1 month, that's the truth, or 1 month or 2 months, that's the truth. It needs a lot of work. But nothing is impossible actually. So if your dream is to work in one of the fan companies, so if you want to work in Facebook, Amazon, Apple, Netflix, or Google.
Ephraim, sorry to interrupt you. Your time is up, so can give for the other presenter.
I'm done already.
All right.
So basically, if you want to work in one of the top companies, you have to know how to use algorithms and data structures. Thank you.
Thank you.